I'm going to take a look at number 5 on page 524. And we'll just take a look at C. So we have a word, Akilaquak. My pronunciation is awful, but we're just going to take a look in how many different ways can you arrange all the letters of each word. We'll just take a look at this one, for example. In this case, to find the total number of arrangements, we take the total number of letters and if they were all different letters, that would be the number of arrangements over the repeats. Now, a lot of students forget to divide by the repeats. So it's important to make sure you divide by the repeats. So if we just take a look at the word, there are 11 letters. There are 4 Q's, 3 A's, and 2 L's. Okay, so what we have now is we have 11 factorial over our repeats, which are 4 factorial, 3 factorial, 2 factorial. And remember, when you're using your calculator to calculate this, you always put your denominator in brackets. Okay, and we have a total of 138,600 arrangements. Okay, now let's take a look at 7. And I'm just going to take a look. The 7 is on page 525. We'll take a look at C first. And what we have is we have 6, pick R, equals 30. And what we're asked to do is to solve for the variable. So let's just take a look at the notation for this. Based on our formula, we have 6 factorial over 6 minus R factorial. This is for permutations, equals 30 over 1. Well, we can just switch the 30 and the 6 minus R factorial. That's all correct. So we're going to go 6 factorial over 30 equals 6 minus R factorial. Okay, 6 factorial over 30. If we break that down, 6 factorial is really 6 times 5 times 4 factorial over 30 equals 6 minus R factorial. Okay, what do we do with this now? Well, 30 is really 6 by 5. 4 factorial equals 6 minus R factorial, or 4 equals 6 minus R. R equals 2. So that's the variable R. It's 2. Let's take a look at D. It's a different question. If we take a look at D, what I have is 2 times n pick 2 equals 60. Well, the first thing we're going to do is we are going to divide by 2 to simplify. 6 pick n pick 2 equals 60 over 2. And if we have n pick 2 equals 30, we can change that notation to be n factorial over n minus 2 factorial equals 30. Now I want to get something to cancel out here to simplify. So what I'm going to do is I'm going to choose the larger term, and n factorial is greater than n minus 2 factorial. Okay? So you choose larger term. And expand. And we're going to get the n minus 2's to cancel out. So what I have here is I have n by n minus 1 by n minus 2 factorial equals all over n minus 2 factorial equals 30. Okay, well, beauty of that is n minus 2 factorial over n minus 2 factorial will cancel out. And now I have n by n minus 1 equals 30. Well, can factor that. N squared minus n minus 30 equals 0. Let's solve for n. You could also use reasoning, but I find this easier. You could go 5 by 6, and you would know. But anyway, let's take a look at this. I prefer. So something times something is negative 30, adds up to negative 1. We have n minus 6 by n plus 5 equals 0. So n equals 6 or n equals negative 5. Now, this one we disregard. N cannot be negative. We can't have a negative number in our permutation. Cannot be, n cannot be negative. I was going to say permitted. Wrong. N cannot be negative value. Okay. So that is number 5 and 7. Number 10. If we take a look at number 10, this one's a bit more complicated. In how many ways can 4 girls and 2 boys be arranged in a row if A, the boys are on each end of a row? Okay, so what I have here is I have boy, 1, 2, 3, 4 girls, and another boy. So boy 1, boy 2, girl 1, girl 2, girl 3, girl 4. Okay, so to calculate this, the number of ways the boys can be arranged is 2 factorial ways, because we can switch the B1, B2s. So boys arranged 2 factorial ways. The girls, because the boys have to be at the beginning and the end, right? Girls can be arranged 4 factorial ways, 4 different arrangements. So essentially, what we have is 2 factorial times 4 factorial will give us 24. Oh, sorry. 2 is 48. 2 by 24 is 48 ways. Okay, let's take a look at the next one. The boys must be together. Well, what we have here is, let's just take a look. We have boy 1, boy 2. And this essentially is 2 factorial again, but here we have girl 1, girl 2, girl 3, girl 4. And because the boys have to be together, this takes up 1 spot. So all of this is 5 factorial spots, because the boys can move around anywhere, but they have to be together. They can be switched around, but they have to be together. So 1, 2, 3, 4, 5. So the number of arrangements is 2 factorial 5 factorial, which turns out to be 240 ways. Last one for now. We'll take a look at C. The boys must be together in the middle row. So what I have here is I have girl 1, girl 2, boy 1, boy 2, and these two can be switched, but they have to be in the middle. Girl 3 and girl 4. Okay, so the boys essentially have to stay in the middle. So what we have here, they're stationary. The boys are 2 factorial. They can switch back and forth, but they have to stay in the middle. And the total number of changes for the girls is 4 factorial. So again, we have 2 factorial times 4 factorial is 48 ways, or arrangements, or whatever they say. Okay. We'll take a look at the following questions in the next lesson.